Okay, welcome back. So we've got our question 3 that we can move on to now, and so we're looking for question 3 here. All right, so for question 3, more practice. So we're integrating e to the 4x plus 3. It's a genuine chain rule, so we just involve ourselves in the steps. Let u equal 4x plus 3. Leaving its notation and staying in the column du dx. Derivative is 4. So after a few manipulation steps, we get 1/4 du is equal to dx. That's actually the substantive substitution we're going to make. So there now, dx is now gone, and 1/4 u comes in its place. 1/4 du, and now this is the trivial substitution, and of course that's the one we love. So the differential of e and u is actually e to the u, and finally we put in the x's, so we get 1/4 e to the 4x plus 3 plus c. That's our final. So it's good practice. It's great practice to be able to do these. Okay, so you must be able to do these. So persevere with it. This is the job now. Okay, the 6 things led up to this. The 6 things led up to this. We must be able to do this. Okay, this is not optional. It's not negotiable. It's not tiresome. This is your career. This is your job. Okay, you must be able to do this. Okay. So you must stick with it, keep working. So we're looking for, just do it the long way until it becomes second nature. Then you can start fucking around with it. So the derivative to u dx is equal to 3. So after some manipulation, we get minus 1/3 u equals dx. Is it up there? Yes, it is. So we're going to substitute out the dx with the du and minus 1/3. Now, what you'll notice is that there's a 5. So we're going to bring that 5 over the front and make it 5. So that's just something we're about to do. That means that the trivial is e to the u. So we can now integrate that as minus 5 on 3. And the integral of e to the u is just e to the u, and that's our result. So the final thing is to put the x's back in, and we can do that. So minus 5/3, practice, 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 minus 3x c. Okay. So there you go. B. All right, we just keep going with it because this is what we need to do. Okay, it's just something. This is the maths that we're going to be faced with. Remembering that if you haven't done calculus at school, this is what you need to be doing. Okay, so this integral here, I might do a bit of pre-work on here. Okay, because I'm going to recognise differentials, differentials around. So a bit of pre-work will be, I'm just going to bring the 11 out the front, and we'll have 1 e to the 7x. That's fine, dx. And we can let u equal e 7x. And the reason that I'm doing this, stay in your column, is because it's a chain rule. So before we can do this, we need to let m equal 7x. U then can be written, because we're doing differentiation, e to the m. So the chain will be built up, the u, the m, and this chain will be the m, the x, and you can see it's going to x through m. So the calculus of that's the one we love, because there ain't nothing easier, and 7x is just 7. So we can put them together as du dx, staying in the column, because this is the one we're going to manipulate, du dx. And so we ask ourselves, once we put the chain together and do some manipulation, if we do some manipulation, we'll have du is equal to 7e to the 7x dx. Okay, so is that all there? And the answer is not quite. Not quite, because we have the 7. There's no 7 over here, so we've got to divide by 7 both sides. That gives us this. Okay, so we've got 1/7 du e to the 7x dx. Now, in a way, there's a bit of a dilemma, in the sense that the e to the 7x term, while it's there, it's on the denominator. Okay. Now we can put it there just as a substitution, because after all, that's what this is about. So we can say, are you there? Yep. Are you there? In a form, you're there. 1/e to the 7x. Okay. Now we can't just say that we dispose of e to the 7x because it is u. It is itself u. So we can just say to ourselves, all right, well, we can substitute it, but perhaps what we would have been better off doing, and I don't mind doing this now, is just writing this in this form. Okay? And this is the beauty of just being a little bit pragmatic and saying, is e to the minus 7x there? Okay, e to the minus 7x there, dx. So even if we did put it in that form and let u equals e to the minus 7x, what does it change? It just changes a few things. And so we can just walk down and say, oh, okay, so these are now minus 7. So we're dividing by minus 7. Okay, minus 7. So we get these remain as minus now, because we've done that little manipulation there. Okay, so we've got 1/7, 1 minus 7 equals e to the minus 7x dx. Okay, so what we get is we get this, are you there? Yes, so we can substitute them out. So we do our du and the integral, and effectively that's u, isn't it? E to the minus 7x is in fact u. Okay, so we've got 11/7 minus, and that's ostensibly our substitution. All right, so if we do the integral of 1, remember this is 1 in disguise, right? The blank, I've deliberately left it blank in the video to say, hey, well, where's it not? Well, it's actually that blank. Because we substituted it out, we were left with a 1. So this is a bit of an unusual case, okay? So on integration, the integration of a blank is we conjure u. Where there was no u, we now have a u, okay? And so finally, this one was a bit tricky. The u is e to the minus 7x, e to the minus 7x, plus c. Now you can put that down the bottom, but what I wanted to show you was that it can be sometimes a little bit tricky, okay? Substituting out both of them, really? You're substituting out both of them, and you get this. You get nothing. Well, you don't get nothing, you get 1. And you had to recognise it was going to be 1. And on integration, yes, on integrating of 1, we generated u. Oh, well, u was our original one. So sometimes it's not obvious what's happened. You've got to be a bit pragmatic and work through it. But ultimately, that's a great way to look at it. All right, so for C, that was that one. That's a good one, isn't it? I suspect E is going to be a similar thing. So let's do the minus thing a little bit earlier. Maybe we'll do that a little bit earlier. This one. Sometimes it's just pragmatism. So we'll integrate 6 over e to the 5x. Okay, 6 over e to the 5x dx. Let's do a bit of pre-work. We'll put the 6 out the front. We'll bring the e to the minus 5x up as a negative indice dx. So we've made it a bit easier. Okay, so we'll let, I like these because they're chain rules, and let u equal minus 5x. We got there eventually in the previous one, didn't we? Now, du dx is, and also makes this a little bit simpler, minus 5 and so we'll get du minus 1/5 du is equal to dx. So are you there? Yep. Now because we've introduced this straight away and changed the form of the integral, this has now meant that we're going to be doing the sophisticated substitution. So are you there? Yep, so you're gone. So we've got minus 6 on 5, the integral of du. Okay, what we're left with now is the trivial substitution, e to du. So this one panning out similarly to the previous one, but I'm just showing you the different techniques. Okay, I'm just showing you what that different techniques look like. Okay, and that's all it is. By using the whole thing there, I probably overcomplicated that one, but this one's fair enough. All right, so we can just do this now. So we get minus 6 on 5. Minus 6 on 5 e to the minus 5x. So minus 6 on 5. So even if you do something, as long as you can work your way back through it, e to the minus 5x, just putting the u's away, plus c. Alright, that's a bit of fun. Alright, e, d, we'll do e because it's a more traditional one and we're being told specifically to use a particular substitution. So we've got x, e to the x squared plus 3 dx, and we're told to let, and this often happens in questions, u equal x squared plus 3, and straight away we're looking for derivatives. The u, the x, is going to be 2x, after a little bit of manipulation, we're going to get, now there's no x, we get the dx. So a bit of manipulation, we're going to get a half u is equal to x dx. Now they're the substantive substitutions. Are you there? Yep. Are you there? Yep. So these are getting knocked off and replaced by du and a half. So that's the substantive substitution. The trivial substitution now follows, and so we're able to do the integration, and fortunately e to the u is e to the u, so we'll just put it straight back up as e to the u, which is x squared plus 3 plus capital C. So that's our final result. So once you get the hang of them, the pattern that's involved is fairly straightforward. Okay. So for f, picking the integrals again, what's the differential in this integral? What's the function? Okay, x squared. Oh, look up here, we've got an x cubed. So on differentiation, x cubed is going to become x squared, so it looks like that's the candidate. So we don't need to be told. We can just go ahead and let u equal x cubed plus 9, and du dx is going to be 3x squared. So after some manipulation, we can get to 1/3 du is equal to x squared dx. Are you up there? Yep. Are you up there? Sure I am. So they are now the substantive substitutions. They're gone. They're being replaced by du, 1/3. So that's the substantive substitution. The trivial substitution is e to the u. So we get the integration of e to the u is e to the u. It just continually follows a pattern. So once you get the hang of these, this is now x cubed plus 9. It's very straightforward. And kids all over the state are doing this coming week. They're doing advanced maths, they'll do extension maths, and these guys will be in it. These guys will be in it. U substitutions will be in it. Okay? So it's just how it is. Alright, so how are we going? We've done F, we might fit G, I think G in. Same thing, in the function to be integrated is the derivative. Okay, cos x e to the sin x dx. The differential of sine is cos, so it seems a reasonable substitution to make u sin x stay in the column. Do du dx is in fact cos x. Well, we did this earlier, I think, as well. A similar example in another video, earlier video. And are you there? And the answer is yes, I'm there twice. So the substantive substitution is simply du, and we're integrating e to the u. Wow! That's the trivial substitution. So the substantive substitution got rid of cos x dx, and all we were left with was this. So on integration, it's e to the u, and u itself is sin x. And of course, you can use technology to check all of that. Okay. Wow, isn't it good? We're able to do that. Okay. So h I'll just do these to finish off this video. Integral of sine 2x, and what can you see? What's the differential and what's missing? Okay, this one is e to the 3 cos 2x, which is a complete distraction because the differential of cos minus sine. Okay, and it's also a chain rule, so this one's going to be a little bit tricky. So we'll let u equal 3 cos 2x. Now, because it is a chain rule, staying in the column means we have to do a chain rule before we can do our manipulation. So we need to let m, building up our chain rule differentiation, equal 2x, and therefore u can be rewritten in terms of m as 3 cos m. Now we can do our chain rule for du dm, and over here dm dx. So they come together to give us our chain rule. So the differential of 2x is 2, differential of 3 cos m. Now the differential of sine is cos, so the differential of cos is minus sine m. Okay, they chain together to give us du dx, which is what we needed up here, and so we have to put them together. So we end up with du dx on a chain. Du dx is equal to minus 6 sine 2x. Now, after some manipulation, we see that we want the sine 2x but not the 6 or the minus, so we're going to end up with minus 1/6 du is equal to sine 2x dx. They are the substantive substitutions. Are you there? Yep. Are you there? Yep. So they're both gone, and they're gone by this minus 1/6 du. So we put our du up, and our minus 1/6, that's the substantive substitution that we did by staying in the column. Okay, we stayed in the column, and e to the u is the trivial. So the integration then becomes minus 1/6. E to the u is the one we love, it's just e to the u, and we can put 3 cos 2x back in for u plus capital C. That's our result. Okay. Very good. All right, the final one, I think I'll put that on the next page. So I'll leave that here for the moment, and I'll do the next video. See you soon.